Okay, we're going to do a couple of problems that might be a little complicated. This one requires quite a bit of steps. Alright, so basically we have two posts that are 12 feet high and 28 feet high and 30 feet apart. So if you look over here, you'll see this post is 12 feet and this post is 28 feet. And then they're 30 feet apart. So the distance between them from post to post is 30 feet. Now, they're going to be attached to these two wires right here. So here's a wire running down here, and I'm going to call it length Y. And then here's a wire here, and I'm going to call that length Z. Okay? And so what we want to do is find out where should I put the stake here so that I can minimize the length of the wire. So what I want to minimize, if you look over here, I'm going to let capital W represent the sum of X plus Z. Actually, I'm sorry, that should say Y plus Z. Alright, so W is going to equal Y plus Z, so it's going to equal the sum of the two wires. And so what I want to do is minimize that length of wire. So I want to minimize Y plus Z. Okay, well, let's take a look at what we've got here. Now, we've actually got, on the left side, we've got a triangle here. And so let me see if I can give you that triangle right there. Okay, so we've got this triangle, and I'm going to call the distance from this end that I put the stake, I'm going to call that X. Okay, so now, since this is a right triangle, we know that X squared plus 12 squared has to equal Y squared. That's just straight Pythagorean theorem. Now, also, so basically, if we simplify that, that says X squared plus 144 equals Y squared. So that's for the left side. Now, let's look at the right side of the triangle. So that would be this triangle here. Forgive me if I'm a little off here on my drawing, but hopefully you can see what we're going to have here. I'll make that a different color. We'll make that blue. Okay, so that triangle, well, the sides of this, if this is X and the total length between the poles is 30, then that's got to be 30 minus X from here to here. And then this is 28, of course that's Z. So using Pythagorean theorem, I know that 30 minus X quantity squared plus 28 squared equals Z squared. Well, if I expand this, I get X squared minus 60X plus 900. And then if I add the 28 squared to that, that's going to give me 1684. So X squared minus 60X plus 1684 is equal to Z squared. Okay? Well, if Y squared equals this, then the square root of Y would equal, then the square root of this would be Y, right? So if I want Y, then I would have to have the square root of this. And if Z squared equals this, then Z would be the square root of this, right? So the square root of this would equal Z. So when I go back to W, I can replace Y and Z with these two square roots. Okay? Now, if I differentiate this and differentiate this, here's what I'm going to get. So let me get this out of the way. So basically, W is actually X squared plus 144 to the 1/2 plus this trinomial X squared minus 60X plus 1684 to the 1/2. And then if I take the derivative of W with respect to X, I get 1/2 this to the negative 1/2, and then multiply by 2x for the product rule. I mean, you can go through the steps, but But basically the 2's are going to cancel here. And then over here I'll get 1/2, all this to the negative 1/2, and then times 2x minus 60. But then the 2 on bottom is going to cancel with the 2x minus 60 and just leave me with x minus 30. Okay, so now, you know, once we get the derivative, we want to find what makes the derivative 0 so we can get the critical numbers. Okay, so now, basically I want to set this equal to 0 and solve it. Well, what I'm going to do is I'm actually just going to take this term and move it to the other side. Now when I move it to the other side, it makes it minus that. Okay? Well, 30 minus x is minus x minus 30. So by just making this 30 minus x, that's the same as saying minus all this. So there, now I have a proportion. So now I can cross multiply. X times this equals this times this. Now, I know it's getting a little complicated here. Alright, but now if you square, now we can square both sides to eliminate the square roots. So if I square this side, I get x squared, and then when I square this, it just eliminates the square root. Remember, this is the square root of all this. So I get x squared times all that. And then if I square this side, well, I'm going to get 30 minus x squared, so it's going to be 900 minus 60x plus x squared. And then when I square this, I get x squared plus 144. Now, if you distribute here, you get x to the fourth minus 60x cubed plus 1684x squared. And over here, if you FOIL, or actually not FOIL, but just distribute, you get x to the fourth minus 60x cubed plus 1044x squared minus 8640x plus 129,600. Well, the x to the fourths looks like they cancel. The minus 60x cubes looks like they cancel. So when you put everything else together, if you take the 1684x squared and subtract this off, you're going to get 640x squared. And then if you move this term over, you're going to get plus 8640x. And if you move this term over, you're going to get, actually you're going to get a minus. You're going to minus that. Now, you can solve, this is a quadratic equation. And remember, if all else fails on a quadratic equation, you can always resort to the quadratic formula. So I'm going to let you do that. Go to the quadratic formula and solve this, and you're going to get that x is 9 feet. So, make a long story short, this stake needs to be 9 feet from the left pole and 21 feet from the right pole. And then you can figure out what y and z is if you want to. But we really didn't have to figure that out. We just had to figure out how far we want the stake to be to minimize the length of the cable. And there you go. It's 9 feet. This one says a box is to be constructed in such a way that the perimeter of the base must be 9 centimeters and the perimeter of a side must be 12 centimeters. So find the dimensions that maximize the volume of the box. Here's the picture. So the primary equation would be volume, x times y times z. So that's what I want to optimize. The perimeter of the base would be 2x plus 2y, which is 9, or x plus y equal 4.5. Now the perimeter of the xz side, so let's say the xz side, that would be this front side, is actually 2x plus 2z equals 12, or x plus z equals 6. You can simplify that. So if we solve the first equation, we can get y equals 4.5 minus x. And if we solve the second equation, we can get z equals 6 minus x. So now we know y in terms of x and we know z in terms of x. So I can go back to this equation and replace y with 4.5 minus x and z with 6 minus x. And I'll leave you to multiply this out, but if you multiply these three polynomials together, you'll get x cubed minus 10.5x squared plus 27x. And now the derivative of this would be 3x squared minus 21x plus 27. and you can factor a 3 out of this. We want to set it equal to 0. We factor a 3 out of this, and so to solve this we need to solve the quadratic equation x squared minus 7x plus 9. So I just went ahead and used the quadratic formula with a equal 1, b equal negative 7, and c equals 9. And so when I did that, I got two answers: 7 plus square root of 13 over 2, or 7 minus square root of 13 over 2, which is approximately 5.3 or 1.7. But the second derivative is 2x minus 7. So if I test the second derivative at 5.3, I get a positive number. So that means that's going to minimize the volume. But if I test the second derivative at 1.7, I get a negative number. So that's going to maximize the volume. So that means that the x value should be 1.7 centimeters. And then you can go back up here and find the other values. Y is 4.5 minus x, z is 6 minus x. So 4.5 minus 1.7 is 2.8. 6 minus 1.7 is 4.3. And if you want the exact dimensions, which I did here, I'm not too worried about that, but if you want the exact dimensions, you could actually find the exact dimensions here. But these are the approximate dimensions here. Okay? And so now we're finished with chapter 3, which had covered applications of derivatives. And so I believe the next chapter I'm going to go into is either integration or exponential functions. I'll have to look at my notes.